This video covers the first three exponent rules that you were taught. We're going to use numbers 13 through 60 on pages 311 to 312 in your book if you want to follow along that way. We're going to start with number 13a, and we're just going to use the rules. So in this case, the bases are the same, so you add the exponents. So we take 5 to the power of 4 plus 5, and we get 5 to the power of 9. So y is equal to 9. 13b, again, the bases are the same. They both have a base of 3, so you add the exponents. When the bases are the same, you add the exponents. So this is 3 to the power of 10th, so y is equal to 10. Number 14, again, the bases are the same. We add the exponents, and we get 5 to the 4th power, so y equals 4. 13d, the bases are the same, so you add the exponents. So basically, w plus 6 should equal 11. So w is equal to 5. Letter E, 1.5 to the power of w plus x needs to equal 1.5 to the power of 6. So w plus x should equal 6. So any combination of two numbers that's going to equal 6 would work. So I'm going to put some values in for w and in for x that would work. So we could use 2 and 3. We could use, oh, not 2 and 3, I don't know what I'm saying. I'm thinking of 5. We could use 3 and 3. We could use 4 and 2. You could always do it the opposite way. You could do 2 and 4. You could do 5 and 1, 1 and 5. We could also, let me start another table over here, w and x. We could use 0 and 6 or 6, 0. We could use -1 and 7. We could use -3 and 9. Any combination where you add it together and it equals 6 will work for w and x. 13f, again, the base is the same. It's a c, so you add the exponents. So we get c to the power of 8. So y is equal to 8. It works just the same when your base is a variable. All right, 7 to the 4th and 7 to the 9th power. This is number 14. And the directions here say, write each of the following expressions in a simpler equivalent exponential form. So we need to leave it in exponential form. So bases are the same. You add them up. So we get 7 to the power of 13. Okay, B, we have 4.2 to the power of 2 and 4.2 to the power of 5. The bases are the same, so you add the exponents and we get 4.2 to the power of 7. 14C, again, the base is the same, so you add the exponents, we get x to the 5th power. 14D, the bases are both C. When the bases are the same, you add the exponents, so it's c to the 7th power. 14e is a little bit more complicated. What we're going to do is we're going to reorder according to the commutative property of multiplication. There's multiplication between each of these pieces. So I'm going to reorder 5 times 4 times x to the 3rd times x squared times y to the 4th times y. And the reason I'm putting them beside each other is because I can't simplify x to the 3rd times y to the 4th because these two do not have the same base. Also, if I multiply 5 times x to the 3rd, it's just 5x to the 3rd. I can't simplify it. However, if I put it by 4, 5 times 4, that's 20. I can simplify that. X to the 3rd times x to the 2nd, bases are the same. You add the exponents. And then here, bases are the same. You add the exponents. And that y, you don't see a power, so you know that the power is 1. So this is 20 x to the 5th, y to the 5th. All right, 14f. This is similar to the last problem where we're going to have to reorder according to the commutative property. So I'm going to write the 7 out in front, then a to the third. There's nothing like the a to the third, so now I'm going to move on to the bases of b. So b times b to the fourth, and then m to the fifth times m to the second. And then I simplify. There's nothing we can do here to simplify. No base is the same as a or 7. That could be 7 to the first if you think of it with an exponent and the 7 as a base. These bases are the same, so we can add the exponents. And these bases are the same, so we can add the exponents. So we end up with 7a to the third, b to the fifth, m to the seventh power. And number 15, we're going to reorder according to the commutative property of multiplication. So I multiply 4 times 10 times x to the third times x times y to the fifth. Let me write that more neatly. So we get 40. You treat this just like you normally would. This is 4 to the power of 1, 10 to the power of 1. The bases aren't the same, so you can't do the rule where you add the exponents. But we know how to multiply 4 times 10. We're allowed to just do 4 times 10 and get 40. Over here, we can add the exponents because the bases are the same. And there's no other base of y, so we just carry that down. So we have 40x to the fourth, y to the fifth. And now 14h. Over here we have a coefficient of -1. Remember, coefficients are the numbers in front of the variables, the numbers multiplied by the variables. So in front we're going to have -2 times a -1. Then we're going to write c to the fourth times c. And then finally, d squared times d when we're ordering using the commutative property of multiplication. -2 times a -1 gives you a +2. Bases are the same, you add the exponents, and we get c to the fifth. Bases are the same, we add the exponents, and we get d to the third. And then there's a 2 in front. So the result is 2c to the fifth, d to the third. And moving on to number 15. In this case, the directions are find values for x, y, and z that will make these equations true statements. Letter A, we're using the rule power to a power, which was rule 2. So we're going to multiply 5 times 2, and we get 7 to the 10th power. So that means that z must equal 10. Number 15b, power to a power, you multiply. 2 times 3 gives you 6. And the base remains the same, so x must be 4.5. 15c, power to a power, you multiply. So 3 times x needs to equal 12. If you want to show this as an equation, you could solve it like I just did. X equals 4. Number 15, again, this is the same rule. Power to a power, you multiply, and you get t to the 21st power. So z must equal 21 for these two statements to be equivalent. 15e, 7.5 to the 4th power. Well, in this case, we have 7 to some power times 5 to some power, and we're using rule 3 where it's power to a group you distribute to each piece. So the 4 goes to the 7 and it goes to the 5. So x must equal 4 and y must equal 4. Number 15f, again, we're taking this 4 and giving it to the 3 and to the t. So x must equal 4 and y must equal 4 for the statements to be equivalent. 15g, power again goes to each piece. So it's 5 to the power of 2 and then n to the third to the power of 2. We have to use two rules here to simplify so that we can figure out what x and y are equivalent to. We took the 2 to each piece. Now we need to use the rule where it's power to a power you multiply. So it's 5 squared and then n to the 6th power. So that's 2 for x, and then y is equal to 6. So x equals 2 and y equals 6. Number 15h, we take the power to each piece. So we have c to the 5th to the 2nd power, and then we have the quantity d to the 3rd to the 2nd power. Power to a power we multiply, so we're applying two rules in this one problem. So we get c to the 10th and d to the 6th power. So x must equal 10 and d must equal 6. And then we're on to 15i. Oh, sorry, 16a. So we have x squared to the 3rd power. So this becomes x to the 6th power, and that was power to a power you multiply. 16b, we start by taking the power to each piece. So it's 5 squared, a to the 3rd to the 2nd, and then c to the 4th to the 2nd power. 5 squared is 25, a to the 3rd to the 2nd power. We do power to a power you multiply. Again, power to a power you multiply. And we get 25, a to the 6th, c to the 8th. 25a to the 6th, c to the 8th. 16c, power to a group you distribute, you take it to every single piece. So this is 3 to the 4th power, x to the 4th power, y to the 4th power, and z to the 2nd to the 4th power. So each got a power of 4. So we have 3 to the 4th power, x to the 4th power, then it's y to the power of 4 times 4 because power to a power you multiply. And then this is z to the power of 2 times 4, power to a power you multiply. The directions don't call for you to figure out what 3 to the 4th is, but 3 to the 4th you multiply 3 times 3 times 3 times 3, and you get 81. And then we have x to the 4th times y to the 16th multiplied by z to the 8th. I don't actually need that multiplication sign there. I don't know why I wrote it. So 81x to the 4th, y to the 16th, z to the 8th power is your final answer there. And then D is a little bit tricky. I'm going to share another video that will help make problems like this make a little bit more sense. The basic idea here is the same. We take the power of 2 to each piece. And in this case, the 2 goes to the entire -5 because the whole -5 was in the parentheses. And then the x to the 3rd is going to be to the 2nd power. So -5 is the base, and you multiply it by itself, and you get 25. Power to a power, you multiply, and we get x to the 6th. So the answer here is 25x to the 6th. And that covers all the problems 13 through 16 on page 311 and 312.